Today we're going to learn a new way to graph equations, linear equations. This is my favorite way to graph. Today we're going to graph using the slope and the y-intercept. So we're not going to make a table. We're not going to use intercepts. We are going to graph using the slope and the y-intercept. To do this, though, you have to make sure your equation is in slope-intercept form. So right here, I want you to write slope-intercept form, which is y equals, who knows it? Mx plus b. Where the m is the what? Where the m is the slope. And the b is the what? Y-intercept. Now, to do this, the first thing you have to do is make sure your equation is in this form. The next thing you need to do is identify the slope as a rise over run. So once you have the m, you need to put it in the form of rise over run. So if it's a whole number, like if the slope is 5, you're going to put 5 over 1, and that's your rise over your run. Okay? The y-intercept, the b, your y-intercept, is your starting point on the y-axis. Okay, so the first three examples, they just want you to identify the slope and y-intercept. So look at the first equation. Is it in slope-intercept form? Yes. What is the slope? So if I want it as a rise over run, what would I write? 3 over 1. What is the y-intercept? 4. Now, look at the next equation. Is it in slope-intercept form? No. So your first job would be to rearrange it. So how would you get this 3x to the other side? Subtraction. So I would have y equals negative 3x plus 2. Is it now in slope-intercept form? Yes. What is the slope? Negative 3 over 1. Does it matter which number you assign the negative? No. You can either put the negative 3 with the rise, or you can put the negative with the run. But you cannot put a negative with both, because 2 negatives is really a positive. So you have to give it to one or the other. You will get the same answer either way. Question? If you put it out to the side, it is still correct. But why are we assigning it to 1? Because we're going to graph with this, and we need to know when we rise, are we going up or down? And when we run, are we going right or left? So you have to assign it to 1 for the graphing purposes. If you put it out to the side, it still has the same value, so yes, it would be correct. Okay, but for graphing purposes, you're going to give it to either the numerator or the denominator. Okay? All right. Excuse me. What is the y-intercept? Is it positive or negative? Positive 2. All right, the next one. What's the first thing we need to do? Rearrange it. So I'm going to go up here. How would I get this 4x to the other side? So I would have negative 2y equals negative 4x plus 20. How would I get rid of the coefficient negative 2? Divide everything by negative 2. Now I need to simplify, yes? So I'm going to bring it down here just because I'm out of room. I have y equals, what is negative 4 divided by negative 2? Positive 2x. And then what is positive 20 divided by negative 2? Minus 10, negative 10. What is my slope? 2 over 1. What is my y-intercept? Do not say positive 10. Negative 10. Okay. Now that you know how to identify the slope and y-intercept, we are going to graph with the information. So let's look at the first example. We have the equation y equals 5x minus 3. Is it in slope-intercept form? Yes. Let's identify the slope. What is the m? 5 over 1. Very good. And they're both positive, so I leave them both positive. What is the y-intercept? Negative 3. Please don't put positive 3. To graph using slope y-intercept, you're going to start with the y-intercept. So we know that this line is touching the y-axis where? At negative 3. So on the y-axis, find 0 and go down to 3. 1, 2, 3. That is a point on this line. Does everybody agree? From that point, we are going to rise and run our slope. Okay? So our slope is positive 5, so the rise is positive. Which way are we going to go? Up. So this is going to go up 5. And our run is also positive 1. Run goes left or right. Positive is right. So I'm going to go up 5, right 1. And that is going to be my next dot. From this dot, I can keep going. Up 5, right 1. And I'm out of space. Do y'all agree? Could I put another dot lower than my y-intercept? But instead of going up and right, I'd have to go down and left. Why does that work? Because if I have negative 5 over negative 1, 2 negatives is a... So is this still a positive slope of 5 over 1? Yes. So I can go down and left, and it will still fall on the same line. So go back to your y-intercept, go down 5, left 1, and you'll see it's still going to fall on that same line. Okay, and then connect. Now, for the purpose of this graph and this assignment, I want you to have at least 3 dots if 3 dots will fit on the graph. If only 2 will fit, then 2 will be sufficient. But I want 3 if they will fit. What do y'all think about graphing with rise over run? I think it's the easiest way to graph. Okay. Let's go to the next one. Is this equation in slope-intercept form? No. I need to move the 3x to the other side. How would I move it? Subtraction. So I have negative 3y equals negative 3x plus 12. How would I get rid of the coefficient negative 3? Divide everything by negative 3. And now I have to simplify. So I have y equals, what is negative 3 divided by negative 3? Positive 1, x. What is positive 12 divided by negative 3? So minus 4. So I need a slope. What is the slope here? 1 over 1. Absolutely, but I need the number, so that's why I put it there. Okay? And since they're both positive, which way will I rise and run? Will my rise be up or down? Up. Which way will my run be? Right. What other way could I have done this? I could do negative 1 over negative 1 because that still has a slope of positive 1. So I could also go down and left. It's totally up to me which one I use. And what really matters is if there's room on the graph to go which way. Okay? Because like if the graph is super zoomed in and I can't go up and right and I can only go down and left, then I have to. Okay? All right, what is the y-intercept? Negative 4. So where do I start? On the y-axis at negative 4. I put a dot. And then I'm going to rise up 1, right 1. How many dots did I say you need? At least 3. You can put as many as you want. I mean, I could keep going this whole thing. It's just going to make my graph more accurate the more dots that I have. Okay? But 3 is sufficient for your assignment. I also could have gone down and left. And you'll see that it falls on the same line. If for some reason you're doing it and it doesn't fall on the same line, you did it wrong. Okay? Because we're graphing linear equations, they're going to make a straight line. All right, go to the back. What's the first thing I need to do? Rearrange. How am I going to get this x to the other side? I can't hear y'all. Subtract. What coefficient does this x have? A 1. Why do you think it's necessary I put it there? Because I need a rise over run. So I need the coefficient 1. Okay, so I'm going to subtract. So I have 4y equals negative 1x plus 6. How am I going to get rid of the 4? Divide everything by 4. So I have y equals negative 1/4 x plus, and I need to simplify 6/4. Since it's a y-intercept, I really don't want it as a fraction because I have to find it as my starting point. So shouldn't I make it a decimal? Yes, so 6/4 as a decimal is what? 1.5. So I need a slope. What is my slope? Where do you want the negative to go? It is totally up to you. With the 1, okay, so negative 1/4. So let's talk about where we're going to rise and run. Since I put the negative with the rise, I'm not going up, I'm going down. The run is positive. So I'm not going to go left, I'm going to go right. Could I have assigned it the other way? Could I have said the run is going to be positive 1 over negative 4? So this way I would rise up 1 and left 4, and you will see both of those will fall on the same line. Okay? All right, what is my y-intercept? 1.5. Now, does this graph have intervals on it? No. So technically, you could go count by 0.5s, right? But for the sake of us learning, let's pretend that they're all counting by 1s. So if I'm counting by 1s, here's 0, here's 1, here's 1.5. Do y'all agree? Okay, so I'm going to rise down 1, right 4. So from here, if I go down 1, I'm at 0.5. Yes? And then I'm going to go right 4. 1, 2, 3, 4. And then I can do it again. Down 1, right 4. 1, 2, 3, 4. Where else did I say we could have gone? Up 1, left 4. So go back to your y-intercept. Go up 1, left 4. Did it fall on the same line? Yes. And connect your dots. Okay, I'm going to let y'all have a second to try this one on your own. Check your slope and y-intercept before you start graphing. Did everybody get a slope of negative 2 over 1 or 2 over negative 1? And the y-intercept of 3. Okay, and then go graph it. Do you have any questions about graphing with slope and y-intercept? Are we okay? Now, before we move on, we're going to talk about parallel lines. What can y'all, and we kind of talked about this when we were solving equations, right? When I told y'all, like, if you solve an equation and you don't get an answer, it's because the lines are never going to what? They're never going to touch. What did I tell y'all that they will have in common? The slopes will be the same. So if you have this equation and this equation, this one is already in y equals mx plus b form, yes? This one, what do I need to do? I need to rearrange it. So I just need to divide everything by 2. So I have y equals 2x plus 3. These aren't, I need to change one of them. Because these are not parallel, they're the exact same. So pretend that this was an 8. Okay, just so that we can graph some parallel lines. That's a typo on my part. 8 divided by 2 is 4. Okay, now they're not the same line, but their slopes are the... So when you graph these, they're going to be parallel lines. So let's graph one of them. Let's do this one first. So I need a slope, which is 2 over, and a y-intercept, which is 4. So let's go graph it. So everybody go to 4. It's positive, so I'm going to go up and right. So up 2, right 1. Up 2, right 1. Up 2, right 1. What other direction could I have gone? Down 2, left 1. Okay, so go connect your dots and make a line. What's still rising? Are you on this one or something? Yeah. So for this one, we need a slope. What's our slope? 2 over 1. What's our y-intercept? 3. So this time I'm going to start on the y-axis at 3. And I'm still going to rise up to right 1. When you connect those dots, they should never intersect with your first line because they are parallel lines. Yes? Do y'all have any questions on parallel lines? Can we skip this one, or do y'all want to do it? Are y'all okay with that? So it's just 2 lines where their slopes are the same. They're never going to cross. They're going to be parallel. All right, let's go do the word problem. So flip to the back. They gave you 2 equations. C equals 150n plus 300, and C equals 150n plus 400. What do y'all notice right away about these equations? Their slopes are the... So that means they are going to be what kind of lines? They're going to be parallel lines. So the question says they want you to graph it. And then it says, based on the graphs, what is the difference of the cost to produce each commercial and air it 2 times and 4 times? What did you notice about the difference in cost? So we'll answer that after we graph them. So let's go graph this one first. So I need a slope. What is my slope? 150 over 1, and it is positive, so up and right. What is my y-intercept? 300. So I'm going to go to the y-axis and put a dot at 300. I am going to rise up 150. Now, I'm not going to count 150 spots. I'm going to rise up 150 places. So from here to here, isn't that 100? And then if I go halfway more, that's 150. Do y'all agree? And then I'm going to rise 1. If you look at the x-axis, is it counting by ones? So I'm actually going to run a whole spot. So there's my rise over run. And I need at least 3 dots. So I'm going to do it one more time. So for every half a spot I'm going up, it's worth 50. So this would be 50, this would be 100, that would be 150, and over 1. And I'm going to connect it. It's going to be array, because we're talking about number of TV airings and thousands of dollars. So we can't have negatives. Excuse me. Okay, now let's graph the other one. What is the slope of this one? 150 over 1. What is my starting amount, my starting point? 400. So I'm going to go to the y-axis to 400, put a dot. I'm going to rise up 150 and write 1. So this is 100, here's 150, write 1. Are y'all okay with it counting by hundreds on the rise? Yes or no? So I'm going to go up 150. So here's 100, here's 150, write 1. I can do it again if I want to. And I'm going to connect my dots. Why are they parallel lines? Because the slopes are the same. Now the question says, based on the graphs, what's the difference of the cost to produce each commercial and air it 2 times? Okay, we'll go to 2. Where am I at for this one? 600. Where am I at for this one? So what is the difference in cost? $100. So the difference between 2 times is $100. They also want the difference between 4 times. All right, so go to 4. It's also what? $100. So then it says, what do you notice about the difference in the cost? It's always $100 more. Okay, please make sure you're following the directions. On 1 through 6, it says identify the slope and y-intercept of the line whose graph is shown below. So I want your answer to look like this. The slope is, the y-intercept is. And do you see how they drew a little triangle for you? That is the rise and the run. They drew it for you. Okay? So let's do number 1 together. Where is this line touching the y-axis? At 1. What is the rise? 2. What is the run? 1. So my slope is 2. If you want to put 2 over 1, that's fine. I do want it simplified, but 2 over 1 would be perfectly fine. Okay? All right. Go down to 7 through 12. It wants you to identify the slope and y-intercept of the line. If they're already in y equals mx plus b form, you are good. Most of them are except number 12. So that's the only one you're going to have to rearrange. Look at number 10. Y equals 1/2 x. Do you see a b? So if it's not there, what is it? Your b is 0. That's where you would start. Okay? All right, go to 13 through 18. It wants you to graph the equation. To graph the equation, you need to find the m and the v, just like we did on our assignment. You need a rise over run and a y-intercept. Please, please, please be careful what the graphs are counting by. Look at number 14. What is the graph counting by? 2's. So you have to count. When you rise, every one you go up is actually going up 2. Okay? So be mindful of that. Okay, flip to the back. 19 through 24 is the exact same thing. You need an m and a v, and you need to start with the v and then rise over run. 25 and 26 says, tell whether the graphs of the two equations are parallel. There's no math involved. All you're going to do is look to see if the slopes are if they're the same, the answer is yes. If they're not, the answer is no. 27, they give you two equations. This equation and this equation. They want you to graph them. So how many lines will you have in this graph? 2. Then they want you to use the graphs to find the difference if it's 48 lessons. Now, you can either use the graph or you can plug 48 into each equation and find the difference. See what I'm saying? Like, you could literally just plug it in and then subtract. So that's totally up to you. Okay, so that's what you're going to do. You may get started.